Hey guys, this is lesson 12.3, sample space. Take out your notebooks and let's take some notes. Sample space is the collection of all possible outcomes in an experiment. So if I do an experiment, it's everything that could possibly happen during that experiment. So here is a sample space for rolling two number cubes or two dice colored red and blue. So I have my blue dice and I have a red dice. So you have one of each and you roll them. What are all the possible outcomes are listed here, and there's 36 of them that could happen. So I could get a 1 on my red dice and a 1 on my blue dice. I could get a 4 on my red dice and a 3 on my blue dice. I could get a 3 on my red and a 6 on my blue. It all depends on what you get. So this is listed out, every single possible outcome. This is a sample space. From there, they might ask you a question like, find the probability of rolling at least 1 3. So what you do is you look for the 3s. And I'm going to circle all the ones that have at least 1 3 in it. This has 2 3s, but it has at least 1 3, so I still circle it. And I look at how many I have, and I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the probability of rolling at least 1 3 equals 11 out of 36 total outcomes. So it's 11 out of 36. Next it says, give the sample space of tossing 2 coins. So here's my first coin. I'm going to pick it up off the table and I could get heads or tails. So I'm going to write those two options out, heads or tails. Now, I pick up a second coin and I could get heads or tails, but then it depends on the first one. So if I first with my first coin got a heads, I could get a heads or tails on my second coin. And if my first coin was a tails, I could get a heads or a tails on my second coin. So these are the possible outcomes or the sample space. If I write them out, I would write this: heads, 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 tails, tails, heads, or tails, tails. This is my sample space. Those are all the possible things that could happen if I threw up 2 coins and they both landed. So then it says, what is the probability of tossing 2 heads? So 2 heads is right here. And so that would be, there's 1 of them out of 4 total. So it'd be 1/4 for tossing 2 heads. Next, it's going to show you how to make a tree diagram. So write this in your notes, tree diagram. And here is a really good example. It says you are going to travel on a river. You have 2 choices of boats. 1, you could choose a kayak. 2, you could choose a rowboat. And you have 3 choices of streams. 3 smaller streams. To the north, the northwest, or the northeast. So, from my kayak, I could go to the north, I could go to the northwest, or I could go to the northeast. For my rowboat, I could go to the north, the northwest, or the northeast. So I have 6 possible choices when I get up to the counter to pay. So it says, suppose you select a trip at random. What is the probability of selecting a kayak and going directly north? Well, selecting a kayak and going north is only this first option. So that would be 1 out of 6 would be the probability. Now, here's a little bit more intricate example. It says, on the last day of school, Mrs. Slot has an ice cream party. She has chocolate, vanilla, and cookies and cream ice cream, hot fudge and caramel topping, and M&M's, Reese's Peanut Butter Cups, and Heath Bits. You can only choose 1 ice cream flavor, 1 topping, and 1 candy topping. Make a tree diagram of all the possible options. So now what you should do is push pause and make this tree diagram and then come back and I'll show you how to do it. All right, first you want to start with your ice cream flavors. So I'm going to start with chocolate, vanilla, and cookies and cream. Next, I have hot fudge or caramel topping. So from each of these, I have hot fudge or caramel topping. Hot fudge or caramel, and hot fudge or caramel. And then lastly, I have M&M's, Reese's Peanut Butter Cups, or Heath. I have M&M's, Reese's Peanut Butter Cup, or Heath. And you just kind of go right in order from what they told you in the problem. Notice I started with what they gave me first. They gave me the ice cream choices. And then I started with the chocolate, hot fudge, or caramel. And then I do the last one, the M&M's, Reese's, or Heath. Whoops, I put caramel. Heath. So these are all my possible outcomes. This is my sample space right here. The tree diagram is the sample space. This lists every single sundae you can make. So you count up the last column. So then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 possible sundaes that I could have. So it says, what is the probability of having a sundae with M&Ms? So how I figure that out is I look for my M&Ms. There's 1, 2, 3, 4, 5, 6. So there are 6 out of 18, or 1/3 is my probability of having a sundae with M&Ms. Now, last, you might want to push pause and copy down this key concept. This is the counting principle. Very, very simple. What it says is if you can choose a shirt in 5 sizes and 7 colors, you just multiply the 2 together, and that'll give you all the possible shirts that you can have. So let's go back to our kayak example. If I have 2 choices of boats and 3 choices of streams, I have 2 times 3, which equals 6 possible outcomes. That's exactly what the counting principle is. Now here they wanted me to make a tree diagram, so I had to list them all out. But if they just ask for how many options you have, you can use the counting principle. So here's a really easy example. How many sandwiches can you make when you choose 1 bread and 1 deli meat from the deli counter? So you look at your breads, and you have 5 breads, and you have 6 meats. So you do 5 times 6, and you get 30 choices, or 30 different sandwiches. Now, if they asked me to write them all out, that would be a tree diagram. But here they just said, how many can you choose? So that's it for your lesson.